Alright, so just a reminder of our general strategy. Make sure we get everything in terms of one trig function if we can. Secondly, determine if it's a linear or polynomial and solve it accordingly to get that trig function by itself. And then finally, once the trig function is by itself, we can get our answers using the inverse trig functions. Okay? So, first thing I want to look at today, there's basically two things I want to look at. One is looking at equations where our angle is actually an expression. It's not just an x. Okay? And then I also want to look at some where the only good way of solving them is to use a calculator. Excuse me. Thanks. So, when I'm working with this equation here, let's say I've got 3 tangent of x over 2 plus 3. I have 3 times the tangent of x over 2 plus 3. Notice here that this x over 2 is all inside the tangent function. Okay? And what that means is that I can start solving this exactly the same way I would anything else. Alright? But I have one extra step that I'm going to have to do at the end. That's really the only thing here. Okay? So, like others, I'm going to get our tangent by itself. So with this one, I know that tangent, in this case of x over 2, equals what? Negative 1. Okay? Negative 1. So, I know from my unit circle that tangent equals negative 1 at what two locations?
At 135.
3 pi over 2 is 7 pi over 2? Pi over 4, I think.
4. Yeah, 3 pi over 4.
And 5 pi over 4.
And 5 pi over 4. Okay? Now that...
Is it 7 pi over 4?
Yeah, it's... Or...
Oh, yeah, thank you. First and fourth. Or second and fourth quadrants. So 7 pi over 4. Thank you. Yeah, Sam?
Why is tangent of x over 2 equal to negative 1?
Because I got rid of this 3 and this 3 by subtracting and then dividing. Okay? We're just getting the tangent part by itself first. Okay? Now, question though. This is not our answer, so what do we have to do?
Multiply by 2.
Yeah, that's all we've got to do is we've got to multiply by 2. Alright? So now our answer is going to be, if we're multiplying everything by 2, x is 3 pi over 2 and 7 pi over 2. Okay? So that's really all you've got to do here at the end is finish solving for x. Okay? Now, one thing that goes along with this is if we are solving on the interval from 0 to 2 pi like we normally do, what's going to happen here? Okay, why? Yeah, this is bigger than 2 pi. Now, could we find an equivalent angle
like a reference?
like a, what's the term we're looking for? Yes, a coterminal angle. This is why we learned all these terms last unit, right? A coterminal angle would have exactly the same thing, right? So what are we going to do?
Isn't that the same as 3 pi over 2?
It actually is. We would subtract 2 pi to get, one lap backwards.
That's 3 pi over 2.
Okay? If you subtract, that's 4 pi over 2. 7 pi minus 4 pi, that's going to give us 3 pi over 2. So that means this is actually our only solution.
Is it always going to end up like that?
Not necessarily. No. Everyone is a little bit different, okay? So you just have to kind of work through it and just double check your answers.
So we have to divide by negative 2 pi, or
Let's subtract.
Hang on. No.
what do you do with negative 2 pi?
I subtracted to get a coterminal angle.
Oh, you subtracted from 7 pi over 2?
Yes. Because this is bigger than 2 pi, right? That's 3.5 pi. So if I subtract 2 pi, I'm down to 1.5 pi.
And should you also add 2 pi again to 7 pi over 2?
Well, here's the thing. We're already outside of our interval, so adding 2 pi would just take us further out. If we were in the negatives, yeah, we would add 2 pi to try to get up into the positives. Okay? So that's how you handle these ones that have an expression. Alright? Sometimes you'll run into this, especially when you're making your angles bigger. Like in this case, we had to multiply. In this case here, we have 2 cosine of 3t. What are we going to end up doing at the end? Dividing by 3. So will this be an issue? No. We're not dividing by a negative, so it's not going to make them like below 0. And since we're dividing, if they're already between 0 and 2 pi, they're still going to be between 0 and 2 pi after we divide. Okay? So in this case, we're not going to run into that issue, but we still would follow kind of the same procedure. Cosine of 3t would equal what?
Negative 1/2. Positive 1/2.
Positive 1/2. There we go. Positive 1/2. And where is cosine equal to positive 1/2?
Pi over 3.
Good. Pi over 3 and 5 pi over 3. So you guys are getting a lot more comfortable with this. That's
Multiply by
good.
3rd.
Okay? So that equals what?
Pi over 9.
No, hang on. This equals 3t. So you're right. We're going to divide everything by 3. And we do get pi over 9 and 5 pi over 9. Okay?
Is it 5 pi?
You guys, you need to find somewhere else to hang out.
That's 18 pi over 9.
Oh, true. I multiplied wrong. Or I
Okay.
divided by.
So does that make sense? Not too hard. Just gotta be careful with it.
So in this one we have 2 answers.
In this one we do have 2 answers. Okay? Every problem's a little bit different. Okay? Now, here's a case where there's really no good way to solve this. Because you'll notice on one side of the equation we have a linear function, we have just x. And on the right hand side we have the equation, or we have the function 2 sine of x. If we were to graph this, you guys know how to graph these. So if we were graphing this, y equals x would look like this. And if we were going from negative pi, here's negative pi over here to pi. If we're graphing sine, at pi we're here, and at negative pi we're at 0. Okay?
So it's where they touch.
It's where they intersect, right? So there's actually 3 solutions here. What's one of the solutions? You can tell by just looking.
Origin.
Yeah, at the origin, 0, 0. So I already know one of my answers, x equals 0. I do need to find this and this, however. Okay? This is where your graphing calculator can come in handy. You put these in as your y1 and your y2, and you can calculate the intersection. The key is just getting your windows set right. Alright, now we've done a lot of that already, so I'm not going to take the time here to do that on this one. We will on the next problem. But here's our graph. Okay? I only have one solution showing, but you'll see up here we found our solution. Okay? And by using the intersection function on the calculator, I found it to be 1.895. Okay? Now, I don't care what the y coordinate is, because I'm just solving for x here, right? So, I got 1.895, so that's another solution. The other solution, it's kind of covered up a little bit here on the picture, but you know that this keeps going and this line keeps going this way. All right, our other solution is down here. And if you did calculate intersect down there, you would actually get a negative 1.895. Okay? So in this case, it happened to be plus or minus. That's not always going to happen. In this case, it did because sine's an odd function and we have the line y equals x, so that's an odd
Isn't that
function
bigger
as
than
well.
pi?
No, pi is 3.14, right?
Oh, never mind.
Yeah. So we're still within, and pi over 2, well, no, we're not pi over 2, we're at pi. So yeah, it's within that 3.14 range. All right, so that makes sense?
Mr. Hickson, where is the intersection on the calculator again?
Hit second calculate. It's above the trace button. Once you've graphed it, hit second calculate and then intersect is, what is that, 4? I forget. It's one of them, you can read.
What would you say the window?
Well, you tell me, what would I set a window to for this?
Small.
3.1, negative 3.14, negative 3.14.
Yeah, I would do, and you can actually even use the pi button. You could punch in, for your x values, I would go from negative pi to pi. And then for my y's, what would you set your y's for?
1 and 2.
No, 2.
No.
2 and
No,
negative 2.
Yeah, check it out.
Negative 2.
Our amplitude is 2. This is why we know how to graph these, okay? So we know how to use our technology. I would even make it go a little bit beyond so you'll be able to see the high and low points. So yeah, like maybe a negative 3 to 3. So it's still zoomed in enough to see things real well, but not zoomed in so far that we can't see the ends. All right? Are you in radians? Yep. Anytime your graph doesn't turn out the way you thought it would, always check.
There it is.
There you go.
Wait, do you ever, whenever you're using sine, doing these calculations, do you ever need to have it in degrees? Or do you
It all depends. In fact, we're going to look at one right now that has degrees. This one, they gave us the interval negative pi to pi, so we use radians. Here's another
Change your
one.
calculator from radians to degrees.
Huh?
How do you change your calculator from radians to degrees?
Just hit mode and highlight the one you want. Here's another one. This one's kind of cool. We have a piece of honeycomb. All right, that's the wax hexagons. They're like perfect regular hexagons, hexagonal prisms, I should say, that the bees will make to store their honey in. And if you've ever had it before, it's really delicious. But here's a piece that actually has this angled part at the top, okay? And they've calculated the surface area of this honeycomb to fit this equation right here, all right? And notice they're saying that theta is between 0 and 90 degrees, okay? So they've written this surface area as a function of the height of the piece, the length of this little hexagonal side, and then also this angle. The angle from the center out to like this edge, okay? So, we have two questions here. One is, what value of theta gives a surface area of 12 square inches? In other words, when does this whole equation equal 12, right? And then also, what value of theta gives the minimum surface area? Okay? So, we have to plug in what we're given first, though, before we could do anything. We're told that the height is 2.4, so S equals 6 times 2.4 times S. S, we're told, is 0.75. So, we plug that in. And then plus 3 halves times 0.75 squared times that big old square root. Root 3 minus cosine theta.
Doesn't say theta is the angle indicated in figure 5.2.
Yes. Oops. Okay, I lost my pen. There we go. Alright, let's put this back up here. Alright, so yeah, so now notice what we have. We have our entire function written in terms of theta. All I did was plug in h and s like they gave us. H is 2.4, s is 0.75. Okay? So, we need to multiply all this together. So that would be 10.8. S equals 10.8 plus 3 halves of 0.75 squared. What does that come out to?
0.84375.
0.84375.
Yeah.
Okay. Times the square root of 3 minus cosine theta over sine theta. Okay. Now the most challenging part of this, guys, is typing it into your calculator properly. Okay. Be careful with the parentheses. You're going to need parentheses around this whole thing. You're also going to need parentheses around the numerator so that you don't just divide the cosine by the sine. And then every time you hit either the square root or a trig function, your calculator automatically puts an opening parenthesis in there, so you need to make sure you close it each time. Alright, so if I'm doing this,
This is in degrees, right?
yes, it is in degrees. So here, if I'm doing, this part here, one of the challenging parts, other than just typing it in accurately, is getting your windows set right. Okay? So let's go to y equals. We have 10.8 plus 0.84375 parentheses. Now this is the parentheses to hold this whole thing in. Then I need another set of parentheses for my numerator. And now I have the square root of 3. I need to close the parentheses for my square root. Minus cosine of x. Close the parentheses for your cosine. And now I need to close the parentheses for my numerator. Divided by sine of x. Close the parentheses for sine. Close the parentheses for this whole big set of parentheses. And now we're able to graph it.
And we put s as x, right?
I put theta in.
No, like we have to have two graphs, right?
No.
Oh,
Not just to look at this. I mean, to solve the questions, we'll look at another graph along with this. But okay. So now I'm going to set my mode. Make sure my mode is in degrees first of all, and then I also need to change my window. Okay. It told me that the angle went from 0 to 90, so that's the first thing. X is going to go from 0 to 90. And then, for the sake of time, I already figured out if we set the y to go from 11 to 13, okay, I put this up here, y min of 11 and y max of 13. That's something that you're just going to have to play with and figure out as you look at it so that you can see it accurately, okay?
Can we just do zoom fit?
Zoom fit rarely works on the TI-84. It's marginally better on the Inspire, but even on the Inspire it's not all that useful. What you might do though is like graph it once and then do zoom box. That's a helpful one. Okay, so now I'm going to graph this. And I see it coming down here. It's leveling off, leveling off, leveling off, leveling off. Oh, and now it's heading back up a little bit. Okay. So, at this point here, I want to figure out part A. What value of theta gives a surface area of 12 square inches? How would I figure that out?
Trace.
When you did a trace, define when y is
You have to calculate something.
Okay, if I do a trace when y is 12, I can punch in different values of x, like 35, and it'll tell me what y is. It doesn't have a function to punch in values of y and get me x. So how do I figure out when this equals 12?
Just make an equation saying y equals 12 and then intersect.
Okay, the table will get us close, but a more exact method would be to come down here to y2 and type in 12. Get that horizontal line. Okay, and if I graph that, it's a little hard to see. So here's where I'm going to do zoom box, and I'm going to come here. And I'm going to scooch up here a little bit and come over and make sure I have the entire window that my solution might be in. Okay, so here's my surface area function. It's graphing that thing again. You can see the curvature a little more. And notice there's actually going to be two different angles. I'm going to have two solutions here. Okay? Now, if I come back over here, one of those solutions we can see right here is 49.9, okay? 49.9. My other solution, that's the one on the left. My other solution is going to be over here. I can come over here, close to the intersection point, and then remember, second, calculate, intersect is number 5. First curve is my surface area, second curve is the 12, and then I'm really close to the intersection, so there's my guess, and I get 59.9, okay? So my second solution here is at 59.9. I'm going to actually put this in here, okay?
So what was the first solution?
49.9. Okay? So here are the two solutions, 59.9 and 49.9.
48.9.